Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation, at least tax-deductible to the extent allowed by law, to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today for exam FM on financial mathematics. Katerina has borrowed $300,000 from Trout Bank. Katerina will repay $100,000 of principal at the end of each of the first 3 years. Katerina will pay Trout Bank a variable interest rate equal to the 1-year spot interest rate at the beginning of each year. Katerina would like to have a fixed interest rate so that she enters into an interest rate swap with Lily. Under the interest rate swap, Katerina will pay a fixed rate to Lily, and Lily will pay a variable rate to Katerina. The variable rate will be the same rate that Katerina is paying to Trout Bank. The other terms of the swap will mirror the loan that Katerina has. You are given the following spot interest rates. For time 1, the spot rate is 4.3%. For time 2, the spot rate is 4.6%. For time 3, spot rate is 5.1%. For time 4, the spot rate is 5.4%, and for time 5, the spot rate is 5.6%. Calculate the swap interest rate for Katerina's swap. And here's the solution. The swap interest rate refers to the fixed rate paid by the party in the swap that pays fixed interest rate. So let us denote the rate sought by R. That's the fixed rate in the swap. The unusual situation in this problem is that the principal is being repaid during the swap. Therefore, the payments of the two parties of the swap will be, I will list them, but I just want you to notice is that actually in the study note about swaps, there's a formula that you can memorize to solve this, but I think you can get the formula just by setting this up immediately, and I will show you this in just a moment. We'll go over the payments that the two sides make to get to that formula. So here it is. At time 1, Katerina will pay $300,000, the principal amount, times R, the interest rate, to Lily, and she will also repay $100,000 of principal of the loan, and Lily will pay $300,000 times R1. That's the spot rate from time 0 to time 1. So that's the rate used for the payment in the first year, which is 4.3%, so that's 300,000 times 0.043 to Katerina, who will use it to make the interest payment on the loan. At time 2, Katerina will pay 200,000 times R to Lily and repay 100,000 of principal of the loan, and Lily will pay 200,000 times, well, the forward rate from time 1 to time 2. That's the rate that will then become the spot rate from time 1 to time 2. And that will be, well, that 1 plus that forward rate times 1 plus R1, the spot rate from time 0 to time 1, must be equal to 1 plus R2, the spot rate for time 2, squared. And therefore this forward rate must be equal to 1 plus R2 squared minus, divided by 1 plus R1 minus 1. So that's the current forward rate from time 1 to time 2. That will be the rate that is assumed. And that's equal to 200,000 times 1.046 squared over 1.043 minus 1. I shall pay that to Katerina, and who will use it to make the interest payment on the loan. And at time 3, Katerina will pay 100,000 R to Lily and repay 100,000 of principal of the loan, and the loan will be repaid. And Lily will pay 100,000 times the forward rate from time 2 to time 3, which can be calculated as 1 plus R3 cubed over 1 plus R2 squared minus 1. because 1 plus that forward rate times 1 plus r2 squared has to be equal to 1 plus r3 cubed. And that's equal to 100,000 times 1.051 cubed over 1.046 squared minus 1. So she'll pay that to Katerina, who will use it to make the interest payment on the loan. And because they entered into a swap, nothing indicates that there's any payment between them as they enter into a swap. The present values of the two series of payments, one by Katerina, one by Lily, those two have to be equal. And so that means that 300,000 are discounted at 4.3% to time 0, plus 200,000 times r discounted at 4.6% over 2 years to time 0, plus 100,000 times r discounted over 3 years at 5.1% to time 0. That must be equal to 300,000 times 0.043. That's the rate used for the first floating or variable payment, discounted over 1 year at 4.3%, plus 200,000 times 1.046 squared over 1.043 minus 1. That's the forward rate from time 1 to time 2. And this payment is discounted over 2 years at the 2-year spot rate of 4.6%. Plus 100,000 times the spot rate from time 2 to time 3, which is 1.051 cubed over 1.046 squared minus 1, discounted at 5.1%, which is the 3-year spot rate, 2 times 0. So these are equal, and all we need to do is solve it for r. And of course you can see that r is a common factor on the left-hand side, so we can factor out the rest, divide both sides by that whole expression without the r on the left-hand side, and that's the answer. Of course, the 100,000 is a common factor on both sides. We can just divide everything by 100,000, and what we're going to get is eventually that r is equal to 3 times 0.043 over 1.043 time plus 2 times 1 over 1.043 minus 1 over 1.046 squared, plus 1 times 1 over 1.046 squared minus 1 over 1.051 cubed. Notice that these reciprocals of these 1 plus interest rate factors to a certain power, these are prices of zero coupon bonds. And if we were doing this with the same principal repayment, then they would cancel out. We would get that standard formula that you're familiar with, 1 minus the zero coupon bond price for the last payment, and at the bottom you would just have prices of zero coupon bonds, but that's not the case here because the amounts of principal are different. So at the bottom we have 3 over 1.043, so it's 3 times the price of a zero coupon bond, unit zero coupon bond maturing at time 1, plus 2 times the price of a zero coupon bond, unit zero coupon bond maturing at time 2, plus 1 times the price of a unit zero coupon bond maturing at time 3. And well, we need to do this calculation, a little bit of it, but it's not so bad. And what we get is approximately 4.777035%. The answer C is 4.78%, so this is almost exactly answer C, and that's the end of this problem. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.